Welcome. Today we're going to talk about solving multi-step word problems. Now, just a little review about multi-step equations, because that's what you are going to get when you write your equation from a word problem. You always begin with simplifying each side of the equation. Once you get it, you use inverse operations to get the variable by itself. Remember to do that. You follow the rules of equations. They're balanced and must remain balanced. What you do to one side, you must do to the other. We eliminate the constant because addition and subtraction undo each other. And then we eliminate the coefficient because multiplication and division undo each other. Usually, remember, you can never divide by 0, and you can't divide by a fraction. Instead, you have to multiply by the reciprocal. So today, you're probably going to have to be doing a little bit of pausing this video so that you can write down the words and then write down the equations that we get from those words and the work. So we're going to start out, first of all, with just a couple of very straightforward. We are going to write equations that fit these. Now, anytime you are working with word problems, always write them down, work the text. That is an English class kind of phrase that means write on the text, make clues, whatever, so that you know what you're doing. We are going to underline clue words, we're going to then put things together, and we're going to see how it builds. As I said, we're going to start with a couple of very simple ones. This says 3 times a number decreased by 9 is negative 36. As I read through that, I'm going to underline some clues. Apparently I have times, that's very obvious. I have decreased by, subtraction, and then our most common word for equals, the word is. Yes, I know it's kind of funny that we use a lot of equals when we're reading a math sentence or a math equation, but when you're putting it in words, is will be the most often used word to represent. That's where our equals goes. As we then read through this, our thing says 3 times a number. Well, that's easy. 3 times, I could use a raised dot, or I could use parentheses, a number. Thing is, I don't know that number, so this number is my unknown. I'm going to use a variable, and I'm just going to put the letter N. We're then following that up with the words decreased by. I know that decreased by means that I am going to subtract. So I'm going to put subtract 9. And then we have is negative 36. And you can literally read this. Now, the thing about this, you actually can remove that raised dot, say bye-bye times, and just move the 3 and the n next to each other. 3n or 3 times n, still the same thing. We now have our equation, which in this case is a 2-step equation. To solve this 2-step equation, of course, we eliminate the constant. That's a minus 9. So we are going to add 9. What we do to one side, we do to the other side. That gives us a 0 pair. We have 3n, and I just brought this down so it didn't ruin the equation, that you could see it if you need to come back to it at a little bit later date. And it's going to be equal to negative 36 add 9. Different signs there. We should know by now that different signs actually subtract. The difference between 9 and 36 is 27. And we're going to keep the sign of the bigger number, so that will be negative. We then need to eliminate our coefficient. It's times 3. We're going to divide both sides by 3. When I do that, 3 3s are 1, or 3 divided by 3 is 1. We end up with 1n, which is n, and it's going to be equal to the quotient of negative 27 and 3, which is negative 9. Easy peasy. Our next one, also very straightforward, doesn't have a lot of fluff to it, says twice the sum of a number and 8 is negative 54. Now, if we're looking at those, we have some clues in here. Twice, that's a clue. Twice means 2 times something. We have the sum. Sum means addition. A number, something we don't know, so we're going to use n. And negative 8 is negative 54. Now, as we look at this, some of you might say, 2 times the addition? Well, remember, the sum is an answer to addition. Ooh, that's going to matter. The minute you see the word sum, know that that is an answer. And what's going to happen is I'm going to move my plus sign right over here where I see the word and. So I am going to actually start out with my number, add negative 8. And because it's an answer and I'm going to multiply my answer, that must mean I have to get it first. The only way to get that first is by putting it in parentheses. To get the answer first, I need to put it in parentheses. Then multiply it so it's actually twice the answer. Remember, order of operations says do parentheses first. That makes this a little bit trickier than, say, the one up above. We then have our is and our negative 54. This then is twice the sum of a number and negative 8. The sum, the answer to addition, is negative 54. As we look at solving this, now this is a multi-step equation. We do have distributing. We are going to distribute, and that means we hippity-hoppity multiply the product of 2 and n, 2n. The product of 2 and negative 8 is negative 16. We have an addition, and it's going to equal negative 54. Now we said we always want to make sure each side is as simple as it can be. Distributing is one step of simplifying. Combining like terms is another, and they're not alike. And the third thing is simplifying signs. So when I see add negative 16, I am just going to change that to be a minus 16. So my equation that I'm solving is 2n minus 16 equals negative 54. A simplified two-step equation. That's our goal. We've already talked about this on earlier lessons. We then, really quickly, undo the subtraction so that we eliminate the constant. What we do to one side, we do to the other side of the equation. When I minus 16 and add 16, I'm getting a 0 pair. I'm left with 2n and 0. The identity property of addition tells me that's 2n. Negative 54 adds 16. They're different signs. Different signs subtract, even though it says add. So I'm actually going to take 16 away from negative 54 because I would have 16 0 pairs. So when I take 16 from negative 54, that's going to give me a difference of 38, and I keep the sign of the bigger number. I'm then going to undo my coefficient. I'm going to divide both sides by 2. 2 halves is 1. 1n is the identity property of multiplication. Leaves me with n. Negative 38 divided by 2 is negative 19. And if you put this back in there and look at this and you say, okay, twice the sum of negative 19 and negative 8, negative 19 and negative 8, negative 27. Twice negative 27 is negative 54. You should be able to put things back into your word problem and have them make sense. Now, it'd be great if we had these kind of word problems all the time where it's just a very simple, straightforward, here are the words. But word problems really are meant as real life. And so we end up getting some fluff. Fluff like we see in this problem. This problem says a group of 5 friends each have X action figures in their collections. Each friend buys 11 more action figures. Now the 5 friends have a total of 120 action figures. How many action figures did they each start with? All right, a lot of fluff there. You have to look for some things that you know. Well, some things we know, it's talking about each of those friends. So when we're talking about each friend, each has that. So one person in that group has X action figures. So each person has X action figures. And you could maybe do something like this. So one person has X action figures. We don't know how many. And then it says each friend buys 11 more. 11 more. So each person has X, and then they buy 11 more. So that 11 more is going to add on to the figures they have. So if I have only one action figure and I buy 11 more, I start with my first action figure and then the other 11 come later. Okay. Now because it said that this is the same for every person in the group, I can say, wait a minute, I've got 5 people that is what they all look like. So I can then go from one person being this to 5 people by saying, if I take my 5 people and I multiply it by what one person has, that's a way of looking at my 5 people. Each had an action figure. They then bought 11 more. So every one of those people did the exact same thing, all 5 of them. It then says they have a total of 120. So if I put together all 5 of them, that totals out to equal 120 action figures. Now, I could go, one person is X at 11, another person's X at 11, another person's X at, but that would make this gigantic thing when, if they're all the same, I can just multiply them all by the same amount and make it a very simple distributing problem. To solve this becomes piece of cake. I do hippity-hoppity distributive property. My rabbit hops and multiplies like rabbits like to do. I have 5x and 55 that are adding together to equal those 120 action figures. I say I'm going to eliminate the constant. I'm going to take 55 off of each side because those are the new action figures they bought all together. Each one bought 11. That means they bought a total of 55. I'm going to say negative 55 and positive 55, or add 55 and minus 55 is a 0 pair. That leaves me with 5x because the identity property of addition, and it's going to be equal to the difference of 120 and 55. So 120 decreased by 55. Now I know some of you can do that in your heads, some of you may do with a calculator. Either way, it's fairly simple, and our difference is going to be 65. We then eliminate the coefficient by dividing each side by 5. 5/5 is 1 times x is x, and that is going to be equal to 13. So my solution to the equation is 13. In answer to the question, how many action figures did they each start with? Well, I might just need to solve it. I might need to answer the question. If I need to answer the question, I would say they each started with 13 figures or 13 action figures. I'm just simply answering it by sort of restating the question. Not so bad if you know what you're looking for and you start to put this into reality. It's real world. Don't let it fake you out. Our next one. A pack of pens costs P dollars each. I know that sounds weird, P dollars, but P for pen. A pack of markers costs an additional $3 each. You buy 3 packs of pens and 2 packs of markers for $16. Now you notice I have a little bit of a visual over here. I have a pack of pens and I have a group of markers. I'm going to use my visual to help me figure this out. So if I have a pack of pens, okay, my pens are worth P dollars. And if I have a pack of markers, my markers, it says, are going to be equal to, an additional $3. An additional $3. What is that additional? I need to add 3. What am I going to add it to? Oh, they're $3 more than the pens. So I'm going to put P plus 3. Oh, that wasn't so bad. I can see my visual right there. Then it says I buy 3 packs of pens. Let's just kind of write that down. I'm going to write 3 packs of pens. So I'm going to buy 3 packs of pens. And 2 of markers. So I'm going to write, I have 2 packs of markers. And that is going to be for $16. So those together are going to equal $16. So if you go to the store, think about how this works. You get up to the cash register, and they're going to pick up a pack of pens, and a pack of pens, and a pack of pens, and take them across the scanner. Or, in some cases, they may go, oh, you've got 3, and scan one of them, and times them by 3. So I can write this as 3 times what my pens are worth. Well, my pens are worth P. And, I've got 2 sets of markers. I'm going to multiply the amount that the markers are worth. But my markers are worth P plus 3. Now, I can't just say 2 times P plus 3. That doesn't work because it's not just 2 times the price of the pen and then add $3. It's 2 times all of that. And because it's all of that price, I need to put it in parentheses. And that's going to be equal to 16. That is my equation. Now I know that that looks like a lot of stuff, but sometimes you need to do a little bit of extra input to get what you need to get when you have a word problem. This now becomes like the ones that we previously did when we were solving multi-step equations. We look at this and we say, uh-oh, we have a parenthesis. Order of operations says start in a parenthesis. Not like terms. What do I need to do then? I need to distribute. I'm going to do hippity and hoppity. That means I have 2p and I have 6, and they're adding together. Those are also being added on to my 3p equals 16. Now I look at that and go, oh, I've got 3 things, but oh, 2 of them are alike. Because those 2 are alike, I can group them together or associate them and say 3p and 2p are going to give me a combined 5p. I have add 6 equals 16, and I now have my 2-step equation. I'm going to solve for p. I'm going to first eliminate the constant by subtracting 6 on each side. When I subtract 6 on each side, I have a 0 pair. I then am left with 5p and 0, which is 5p. Over here, 16 take away 6 is 10. I eliminate my constant, or my coefficient now, and divide both sides by 5. 5/5 is 1 times p is p, and that's going to equal 2. I've solved my equation, but remember, this is a word problem. Have I answered my question? So I go back and I look at it, and it says, write and solve an equation to find the price of both the pens and the markers. Okay. So what I found here is that pens cost $2. That's what P was. And markers, well, remember what we said. Markers were P plus 3. If P is 2, and I add 3 to that, I'm going to get that my markers cost $5. So pens cost $2 because P was pens. Markers cost $5. And there you have it. Piece of cake. We're going to move on, try one more of these. As we look at this one, a little bit of airline travel. It says a family of 6 buys airline tickets online. Travel insurance costs $19 per ticket. The family is charged a total of $1,116. How much does each airline ticket cost if they are all the same price? First, we need to know about the tickets. So, each family member they buy a ticket. Oh, but they also have to pay the insurance. So, travel insurance costs $19 per ticket. So that per ticket is an additional amount beyond your ticket price. If I want to write that, I could simply take T for ticket plus the amount I know the insurance is, and the insurance is $19. This is what each person pays, or each person is charged for. I then see that I have the whole family being charged a total amount. Well, I could write this down for each family member, but it'll be much easier because it's repeated addition to instead say, oh, I have 6 family members and each person is going to pay a total of T plus 19. This is the entire amount per ticket. So I can multiply that by 6. And the whole entire total charge is $1,116. This will be the equation that I am going to solve. To solve this, quite simple, I'm going to distribute. I'm going to do my little hippity and hoppity. 6T, and then 6 times 19, you might want to do a little multiplication. You could do it on a calculator. You could do it maybe in your heads, or maybe you might just want to say, all right, I'm going to multiply 6 times 9, that's 54. 6 times 1, that's 6, and the extra 5 is 11. I actually distributed when I did that because it was 6 times 9 and 6 times the 10. So I have distributing inside distributing. I'm then going to add, and that equals 1,116. Now you can leave the comma in it or take the comma out. Sometimes if you take it out, it makes it a little easier for solving. We are going to now solve this by first eliminating the constant, and what I do to one side, I do to the other side of my equation. This gives me a 0 pair. I will have 6t, add 0 is 6t, and I'm going to find the difference of 1,116 and 114, which ends up being 1,002. I'm going to divide both sides by 6. I'm going to have 1. Now, if you don't have a calculator, this is an easy problem to do anyway. It's just a little bit of the 4th grade math. Put your numerator inside the box, put your denominator outside the box, and then we're just dividing by 6. 6 fits into 10 once, that would be 6. The difference there would be 4. I want to make it bigger, so I'm going to bring down a 0. I now have 40. 6 fits into 40 6 times, which is a 36. And you might go, oh, wait a minute, I'm getting a 4 again. But my next number I'm bringing down is a 2. So this isn't really repeating. And 6 fits into 42. 7 times, 6 7s are 42. I have no leftovers. If I did, I would need to put a decimal and put several zeros, then maybe round it off to 2 places after the decimal. Because after all, this, is actually money. So this is money. Sorry about that. My smartboard, sometimes a little haunted. So here we have T equals 167. In answer to the question, each ticket costs $167. Feel free to replay this. Sorry about what happened with my board. That happens quite frequently to mine. It's just something that we deal with all the time. So, go back, think about them, look for clues, reevaluate, see where clues might be. Have fun. Word problems are an exciting way to spend your day.